In this video, we will learn about electric potential and electric potential difference, which is also known as voltage. So, electric potential, or just potential, is simply a measure of the electric potential energy per unit of charge. This is the basic equation for calculating the electric potential, which shows that the electric potential V is equal to the electric potential energy U divided by the charge Q that would be placed at a point some distance away from the main charge. The electric potential energy is equal to the Coulomb's constant K multiplied by the charge that creates the potential, big Q, times the charge that would be placed at a point some distance away from the main charge, small q, and divided by the distance r. In order to calculate the electric potential, we just need to divide the potential energy with small q. Here we can notice that small q appears twice in the equation, so we can cancel it out, which leaves us with this simple equation. The equation shows us that the potential is directly proportional to the amount of charge. As the charge increases, the potential increases, and opposite, as the charge decreases, the potential decreases. On the other side, it is inversely proportional to the distance r, because as you move away from the charge, the potential is going to decrease, and as you move closer to the charge, the potential is going to increase. Finally, we would get an amount of electric potential energy that each unit of charge would have at that point. Now let's go back to the basic equation. We know that electric potential energy is measured in joules, and the unit of charge is coulomb, so the unit of measurement for electric potential is joules per coulomb, or in one word, volts. Here's an example. There's a point charge equal to plus 2 microcoulombs, and we want to find the electric potential 15 centimeters away from the charge. Now we can use the equation in order to calculate the electric potential. The potential is equal to 9 times 10 to the 9th Newton meter square per coulomb square times 2 times 10 to the minus 6 coulombs and divided by the distance 0.15 meters. Here we can cancel out coulombs and meters and we are left with Newton meter per coulomb. Newton meter is the same as joule, which leads us to joule per coulomb, or volt, so the result is going to be 1.2 times 10 to the 5th volts. We got a positive electric charge. In case we had a negative charge, let's say minus 2 microcoulombs, the electric potential at the same point would be minus 1.2 times 10 to the 5th volts. We would get the same value but with the minus sign. Let's take a look at this graph of electric potential. The x-axis shows the distance away from the charge, while the y-axis shows the electric potential at a certain point. Here we have a positive charge and the potential around a positive charge is always positive. As you move away from the charge, as the distance from the charge increases, the potential becomes less positive and decreases, getting closer and closer to zero. On the other side, we have a negative charge and the potential around the negative charge is always negative. As you move away from the charge, as the distance from the charge increases, the potential becomes less negative and actually increases, also getting closer and closer to zero. Here we can notice that if you are infinitely far away from the charge, then the potential is going to be zero for both positive and negative charges. Now we can move on to the electric potential difference or voltage. By definition, the electric potential difference or voltage is the difference in the electric potential between the final and the initial position when work is done upon a charge to change its potential energy. Or the electric potential difference, delta V, is equal to the potential in the final position, Vf, minus the potential in the initial position, Vi. Let's take a look at an example which will help us easily understand the term electric potential difference. We have a positive charge of 1.6 times 10 to the minus 19 coulombs. It is the main charge that is creating the potential. The first circle is the first energy level at a distance of 2.5 times 10 to the minus 11 meters away from the charge. The second circle is the second energy level at a distance of 4.2 times 10 to the minus 12 meters away from the charge. In order to find the electric potential difference, we need to find the potential at the point A and the potential at the point B. The potential at the point A, which is the first energy level, is going to be 57.6 volts. The potential at the point B, which is at greater distance, is going to be 34.2 volts. Now, first we are going to calculate the potential difference as we move from A to B and then from B to A. In the first case, A is our initial potential and B is our final potential. So the potential difference is going to be the final minus initial potential, or 34.2 minus 57.6, which is equal to minus 23.4 volts. We got a negative potential, or as we go from A to B, the potential decreases. In the second case, B is our initial potential and A is our final potential. So the potential difference is going to be 57.6 minus 34.2, which is equal to plus 23.4 volts. We have a positive potential, or as we go from B to A, the potential increases. What does that mean? As we go from A to B, the electric potential decreases due to the fact that we have a positive main charge and its electric field lines point outwards. If we place a positive test charge in the first energy level, the electric potential energy will be larger, because the point charge will repel the test charge and the density of the electric field lines is much stronger. In B, the density of the electric field lines is weaker and the electric potential energy is smaller.